be paying attention too to, I can write in C and C++. Would I like to make a game for this? Just be kind of checking in and see if it's pinging on your interest meter or not. So, are you guys ready to go? Okay, so I'm going to introduce Joe Vasquez, and Joe is actually from the RTIS side with a CE minor, and then I'll let him deal with the rest of the thing. So please give him a warm welcome. Thank you.
Ladies, do we have ladies? Yeah, there's a couple. Ladies and gentlemen, you are about to see DigiPen's first game console, a handheld game console. Okay, are you ready for this? I'm RTIS too, so I'm gonna try to tell you what these geniuses can do, but I don't understand half of it. All right, so be prepared. We're gonna show you the Auger. So let's start with Robert Anderson.
And actually, just a moment, we are leaving the lights on because we're filming it, so we want to be able to capture it.
All right. So that's Rob. This is Hi. Hi, Rob, and Chris are our 3 CE guys on the team. Okay, and these guys have been working for a year and a half now on this console. A large portion of that time was without an instructor. So a lot of the stuff that they've accomplished was on their own, trying to learn stuff, and DigiPen graciously throwing whatever hardware we wanted at us. So, can you guys read this in the back?
Yeah.
All right, good. So, Chris here is our captain and leader of the team. He's here until 10 p.m. all the time, and he's worked his butt off, and so I wanted to kind of give him that honor to say that now. He's done, I don't know, half the system. Then also we have Hi over here, who's done a lot of work on stuff I don't understand, a lot of board design stuff. We have Rob here, who's had to play the part of an RTIS student through the first year of the project. He's had to learn how to write a software graphics pipeline and all kinds of stuff on his own. Also we have Adam, who came in at the beginning of the semester along with me, who's been writing apps for our console. And then I just kind of fool around and try to make it look good. So let me start off by telling you the, actually let me let Rob tell you the idea and inspiration behind the console, because he's the passionate one on the team. So let's hear it, Rob.
Thank you, Joe. So we wanted to do something called augmented reality, and probably most of you have either somewhat heard of it or not heard of it at all. So augmented reality is basically you take the real world and you take a virtual image and you put it on there. So an example would be Ghostbusters in real life. So you got ghosts running around, maybe they pop out of some blue colored objects and you shoot them down. So, and the definition is right there. It's a term for a live, direct, or indirect view of a physical real-world environment whose elements are merged with or augmented by virtual computer-generated imagery. So here's an example. Basically, there's Hi. He's our real world, and this is a futuristic Auger that's just an image that's not real.
So what this image is sort of hiding is that in real life, Hi could be holding a little piece of paper with a special symbol on it, right?
Yep.
And when you look at him through the camera on the device, you see that there's something else in his hand. That's augmented reality.
That's one way of doing it. It's using a system called glyphs. You make some sort of design, and you use image processing to detect it, and then you put your image where that goes. So our original concept, this was what we wanted from the get-go, was we wanted this real-time processing, and we really wanted it to be the real and virtual. So we made sure that we could do that with a camera and MCU, and kind of like, we kind of got a graphics unit on it, but right now we're using the CPU to do that. So we want the 2D and 3D capabilities. So you can put sprites on the screen, but you can also have boxes or models drawn. It needs to be mobile and pretty lightweight, and that pretty much anyone can program for it. So here's the beginning. So we start out with an MCU, and that's short term for a processing unit, CPU of some sort. So we chose the ARM9, which is probably something you guys have used or know about, like iPhones. iPhones have ARM processors in them. A lot of your units will actually have an ARM.
The ARM9 is actually the same exact processor core that the Nintendo DS uses.
Okay, so then we have another big unit called the FPGA, which is Field Programmable Gate Array. Basically what this is it's a big chip with tons of little gates in it. Think of your AND gates, your ORs and whatnot, but you're creating them. So basically you write in a special programming language called Verilog, and it turns it into this JTAG, and then it sets all the little gates and it runs it. So what you can do with this that you can't do with anything else is it's asynchronous, and therefore you can have 400 lines or whatnot and just pump out all this information all at once. So think of it as a big pipeline.
So in RTIS speak, what that means is that we have a big chunk of hardware that we can use to configure into whatever kind of hardware you want. Right? And so if you have a little circuit, right? If you have a processor, if there's something that you need on the Augger, to some extent, we can create that by coding it up in a language that'll fuse those little gates together. And all of a sudden that chip is acting like whatever chip you want it to.
Basically, it's going to work like a graphics card in the end.
Yeah, that's the goal. And then we got the LCD, which we chose is actually the PSP screen. So it's made by Sharp. But we have kind of a little bit of flair on it. So we actually have touchscreen capability because it's actually built in with the screen.
So the screen is 480 by 272. We're not fooling around with little screens, guys. This is a big resolution screen.
All right, so I'm going to step you guys through the initial process. So throughout this whole development, we really started out with nothing, and we didn't know what to do. So of course, there was a lot of researching and assembling of different components. And after that, we had to test what the components can do and what it can't do and what we can do with it. So the time process took a lot of effort. And with the development style that we used was a mix of spiral and agile development, because we just kept reiterating our project until we got something that worked. So here's a couple pictures of our beginning process. Over to the left is what you would call PCBs. It's printed circuit boards. And we had to do that to use some of the chips that we got because they were too small. So we had to make our own PCB boards. And over there is like the breadboarding stuff that we had to use. All right, so the preliminary thing that we did, we used the ARM9. First of all, we had to create an operating system to be able to use the ARM9. And then after that, we tested all the peripherals that we want on there. Camera, flash memory, RAM, accelerometer, compass. And then after that, we had to integrate it all together.
So if you guys have ever used an operating system and wished it would do something that it doesn't do, these guys wrote the operating system. It can do whatever you want it to do.
Okay, so here's another picture of the demo board for the ARM9. We did not make this board, we bought it. So that board just has the ARM9 chips and some other components to make it work. So we had to read out a bunch of documentation to see how it worked and interface with it. So over there you see a whole bunch of peripherals like the camera, accelerometer. Yeah, and the other picture is the same. So we then went on to integration because at this point in time, we already have something going on. We have the operating system up. We have an HRIN, which is the highest rate response. This is to simulate a real-time operating system. Some of the peripheral that we got at this point was the camera, the accelerometer, and the compass, and of course homemade PCBs to make all this work together. And this is our prototype board. As you can see, there's a whole bunch of wires, and yeah, it looks like a mess because it is. We didn't know what to do. So.
Is this your current prototype or an older prototype?
No, this is our first prototype.
Okay, so we move out of the prototype stage, and we actually know kind of what we're doing now. So this is when we start building our architecture. We start figuring out, okay, we want to make the file system. We're going to make some kind of DOS application. SD card, we decided that close to the beginning that we wanted to have some kind of external access to this thing. LCD output, just basically getting the devices to work. We figured out sort of what our architecture is going to be. So now we're kind of putting it together, choosing the RAM, types of memory, and that sort of thing. So this is that process. We have, on the left, we're working the LCD, basically doing a demo of that, trying to get that to go. Working with audio DAC to generate our sound. And then here is basically the first official architecture revision of the Augger. It's a two-board design. We did it in phases, LCD and the microcontroller board, and they're connected together. This is basically just showing the proof of concept. So from that board, we made improvements. We obviously want to make it into one board. And we also enhance the memory interface. So we learn things like, okay, we don't need some of these devices over here, or we need more memory for video RAM, things like that. One of the other things that we realized is we needed a lot more memory due to the size of our screen for just general purpose system. So we added that. Touch screen, we add that in, and audio like we saw in the last slide. So then we reach our final integrated system. We have two variants. This is this guy in the flesh. And basically these guys are the same architecture, just this one has updates that we fixed and changed in here with the addition of a couple of new devices.
Okay, so we sat through a lot of technical stuff. Now let me tell you what this thing can do today. Okay, we have more peripherals than you could ever figure out how to use, but we know how to use them. But yeah. So right now we have audio coming out of this thing, and we have an audio jack. You have speakers, and you have audio out, right? To plug in, whatever. We also have microphone support. So for all you Nintendogs lovers, right? You got the touch screen, you got the microphone. Okay. We also have a digital compass, right? What is that? Okay, so you can turn the thing, right? You can know which way is north, or which way we say is north. Okay, hard coding. Right? That's your new north. And we have a camera, right? You can composite the image on the camera to the screen, and then you're going to be able to draw on top of it. We have accelerometers in here. We have a bunch of stuff that's not even on here, and I always forget every time I'm telling somebody how much stuff we have, because it's so tricked out. So right now we have the FPGA trying to do muscle work for the MCU. One thing that's happening is that the ARM9, right, is the CPU, and it's trying to do a lot of work like rendering. This is stuff that we're going to move off into that special magic chip we talked about earlier called the FPG something, right? So anyways, what we will have is our own graphics card that we've designed and implemented running in parallel with the MCU. We're doing this so that you guys can have graphics that you shouldn't be able to have on this handheld, but you will have on this handheld.
Do you have a debugging system built into this?
Yeah, so the system has Bluetooth as one of the many things, and this is good for debugging because wirelessly you can have like a standard output coming on your computer screen from the Augger as you're playing the game. You can connect the Augger to a computer and run the debugger. Very nice. You can set breakpoints and stuff while you're playing on the console. So it's like a dev kit.
I mean, is there real-time debugging and hardware
Real-time,
debugging?
baby.
No, I mean, is there real-time embedded debugging and hardware debugging as well as API software debugging?
Yes, there is.
Okay. Which of you maintains all those debug stuff? Who knows how the debug works?
We all use the debug.
Oh, okay, go on. Okay.
Actually, and now that you mention it, I'll just shout out, we have like the most pimped out memory manager that Chris wrote. Where like on the fly, like we thought we had a memory leak and we were working on stuff the other day. And so he just connects wirelessly to the Augger as it's running, right? Sets a breakpoint and it stops. And he takes a look at how much memory is in use and how much has been deallocated and all that stuff. And this wasn't something that like he started up the system in the debugger, right? He didn't like, okay, let me compile and debug mode, blah, blah, blah. No, he's running the thing, he opens, he connects wirelessly through Bluetooth and says, okay, stop now. I don't care how you started, stop now, let me take a look. It's all in there. Okay, so what else? You can take pictures with the camera. This is something that I love to do with the camera. There's not much else I do. But it's awesome to do it on the Augger, okay? We have VGA out on this thing, okay? So like when you go home and you want to play it on your, plasma, 1080p screen, right? Well, maybe you want HDMI, right? But anyway, we got VGA, and so this is great too because then you can have like this external monitor that you're looking at things, so you're not trying to look at the screen, even though our screen is fat, right? 480 by 272, it's a big fat PC, what is it, PSP screen? Yeah. So anyways, you can also have this external monitor to look at things close. So Chris mentioned before that that because the resolution is so big, we need a lot of room to store all this data. So right now we're pumping out 16-bit color just to try to keep up with this big fat screen. In the spring, I'm getting ahead of myself here, but you're going to see that improve dramatically. I mentioned we have debugging. It's through the GNU debugger, right? And I mentioned how awesome it is. We have executables. Does anybody else here have executables? Nobody? Okay, do I need to say what that is? All right, here's what that awesomeness means. What that means is that you can take the compiler and you can build your little app, put it on an SD card, plug it into the system, and play it. Okay, so you're not going to have to like plug the system into the computer through some serial port and like try to do a bunch of stuff. No, you can work on this game at home or wherever, right? Store the little executable. It's called an Augg file, right? Because it's the Augger. So you can put the executable on your SD card and then go take it and plug it in the system whenever you get a hold of it. Because maybe your buddy's using it, whatever, right? There's not like a whole lot of these to go around. Anyways, yeah. So that you don't have to be tied to the system to work on. And so let me let Chris tell you in a more technical way some of all these things.
Yeah, so we're going to go a little deeper here. So the idea of the architecture is that everything is going to be memory mapped, which basically means it's going to be easy for you to use. So we have all this different memory, double buffered VRAM memory for the LCD screen. We've got our system memory. We have a couple of banks of that, which amounts to 2.5 megabytes. Some of that's obviously going to be used by the system. We have some audio RAM. And basically, all this memory is a share between the microcontroller and this FPGA, the graphics one we're talking about. I haven't talked about the memory guy, but he's not really doing much. He's just, well, basically making our system cheaper. So, this is basically the architecture, and all you really need to know is that it's just memory map. You get a pointer to these banks, and boom, that's it.
So what he's saying there in CE speak is that even though there's 5 different RAM chips on the system right now, right? You don't have to worry about which one you're accessing in terms of doing something special, right? If you just have a pointer that's in some range, then it's going to be mapped for you into some memory bank. And so if the pointer's between this range and you use it, you're accessing this memory. If it's between some other range, you're accessing some other memory. You don't have to worry about I don't. Has anybody taken the? I'm gonna break my NDA. Anybody taken the Wii or DS classes?
One.
What? All right. Then you know what I'm saying, don't you? Is that awesome?
Yeah.
All right.
All right, thanks, Joe. So onward to peripherals. These are the current peripherals that we have available. The hookups here are really not important. We got camera, light sensor, touchscreen, rumble, accelerometer, compass, microphone, IR. We got an IR thing. You know, we got, you name it, we got it.
What can I do with the IR thing?
So IR thing's not been used yet, but it's there.
What can I do with it?
You could actually check for distance if you wanted to. So, Joe touched on this a little bit, our executables. This is actually how they work. So you take your C+ code, and yes, you can use the STL. Yes, you can use templates. You can use inheritance. You can use new.
Let's hear it.
Yeah.
You know what I'm talking about.
If you really want to, you can use assembly, ARM assembly. That's okay too. So all that goes through, make file project, boom, down to the GNU ARM.
Cut it in real quick. You can build it from Visual Studio.
Yes.
He set it all up so that you just click build, it goes through the app and generates your executable.
We have a makefile that'll do all this for you. You can use any IDE you want. It'll just run the
That's
makefile.
crazy.
Yeah, Joe's using CodeBlocks, I think it is.
Yeah, they're using
Dang.
Visual Studio 2000 next year.
Yeah, so anyway, we're compiling the new ARM. What actually happens is our apps, they link against our firmware build. So every time we make a change in the firmware, we'll just have to, all we have to do is rebuild the apps, and they're ready to go for our system. This is really nice, and actually kind of a pain in the neck as well, but I'll tell you why it's not so bad. Because this is going to result in really fast running apps. Otherwise, we're going to have to like really be interrupting the system and figuring out where these functions go. So that's why we do that. And then we take this .elf file, which is our which is the standard, I think it's Linux executable file. We can convert that to our Aug, put that on the SD card. Our firmware sees it, loads it up, allocates, and calls your main. And that's it. That's running after that.
So what this means is as we're continuing to work on the firmware, right, to give you new functionality and to speed things up and all that, you have a very streamlined system of rebuilding the games you've already made for this new firmware, right? You run make again, or in Visual Studio you hit the
Rebuild.
Control F5, Control Shift B.
Okay. So our future implementation that we want to have in our next build, and that's so you saw version 2. Well, it's going to be version 4, but we call it Augger++. So basically, it's going to have dedicated camera banks. That's a huge thing.
Memory banks.
Yep.
That's what that.
Faster RAM, so you can do more operations, and it's going to have larger system RAM, so you can store a lot more
How
into
much?
RAM.
Oh,
16
megabytes.
16
Whoa.
Pretty awesome.
Now, when you say future, like how far in the future?
Spring.
Spring, yeah.
Those flowers bloom.
Boom.
Oh, plus, which reminds me, you guys, most of these guys are graduating. So if you want to build a game for this, you have to do it this spring while they're here before they go get jobs. Okay.
Then you can tell us what you want, and we'll put it in the firmware. We'll do whatever you need.
So then we also have a 3-axis compass. Well, the compass we have right now is only 2-axis, and not very useful. I mean, you tilt it and you got screwed up values now, so gotta fix that. It's gonna have a smaller footprint, so if you see this guy, he's huge. He's massive. This thing is beast. It's a beast. So
But it's so thin and lightweight.
yes.
I noticed.
Well, this is actually going to get smaller, probably close around to PSP size. So it's going to be pretty small. We're going to use audio codecs. So we're going to have a DAC that actually does all the audio for us. It can play AUGs, MP3s, waves, whatever.
Without keeping your CPU busy.
Yep. So capabilities, we're going to have fast 3D graphics running on the FPGA. That's our huge goal, is to get that FPGA we talked about and make it a graphics unit. That's what we want. We also want to have the VGA and the screen working together, cloning. So we currently do not have that, but it's going to be implemented. And a mesh network, so you can play your multiplayer games. Everyone loves multiplayer, right?
Yeah, woo! Yeah.
So
Local wireless.
We can each get out our own Augger and play.
Yeah. Yeah.
And it's not that it's like only 2-player, and it's not that it's only 4-player. It's like, what is it? Is there a limit on this?
I don't know what the limit is.
All right.
Don't know yet.
So this chip that we're going to put on it is going to create a network mesh for you on its own. So you can still run client-server apps if you want to do your multiplayer that way, right? But you have a mesh network already set up for you as soon as you turn the thing on. Oh, this is my slide. All right. All right. So you guys want to hear about graphics, right?
Yep.
Yeah.
All right. So we could have come in here and told you that we're making this system and it's got a 3 gigahertz processor, and it's got 4 gigs of RAM, and it's got a 160 gig hard drive. And a lot of you should have said, well, I've built my own PC too. So you're getting your degree for that? Get out of here, right? So in looking through the catalog for graphics chips, we decided we're going to make our own. Holy cow. So and these guys don't take graphics classes, right? So anyways, we're using that FPGA, right, that configurable piece of hardware that can become some other transformer thing hardware. And we're going to program all the stuff out of my old GALE classes in hardware. Okay, so we're building our own graphics chip, guys, and it's going to do all kinds of awesome next semester. So you're going to be able to actually give like a list of data, like a list of triangles or vertices, right, and have it run some batch processing by doing like a bunch of dot products or something, right? You could use this for physics. It doesn't even have to be for graphics. We're going to have a 3D pipeline, right? You're using vertex arrays. Okay, like, and so, anyways, you're kicking these over to the GPU and letting it do the work. So, something so cool. I have to say now. I don't even know where he is. But so, this is like a fixed pipeline, right? But who's fixing it? We are. So if you want an app that has some crazy shader effect, we can do that. I mean, we change code, and then we reconfigure this chip. I mean, you literally like plug it into the computer, right? Hit program, boop, 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 boop. It totally changes the whole configuration of this chip. Okay. So if you have some special app where you want some tricked out shader effect, that should never be on a handheld because it's impossible. It's possible. You just have to drop off something else. Anyways, the chip has like a limit of it only has 15,000 logic elements, and if you care what those are, you can go read your digital electronics book. But anyways, it means awesome. So one of the early things that we're going to get is when we start rasterizing on this thing, right? When we interpolate a pixel color, well, at this point we can do whatever we want, just like a fragment shader, right? And so per pixel lighting will be one of the first things on this console. All right, in the spring, when the flowers bloom, the pixels go boom. You got bloom, you could have bloom in there. You got a question?
Yes.
Well, sure, why not?
That's a fixed function per pixel lighting. You don't throw a shader for?
No, right, you don't have to write shaders. We do, in hardware. So
Hardware
don't
means
go too
fast.
crazy. Yeah, right, exactly, yeah,
Fast.
yeah.
And it means by God fast. No drop frames, no when the CPU gets time for it.
That's right. So I'm writing code right now. I'm actually working on this rasterizer right now. And I am limited by the amount of time it takes for electrons to go through this anchor. So go get an electron. That's, I mean, literally, that's my clock. My clock is propagation delay. Is that awesome or what? Okay, so anyways, that's all good. And what the other RTIS guy on the team kind of reminded me was, what about all this other stuff, that we want? When you give an SDK to somebody, right? Give me an easy way to load my models and stuff like that. So this man is going to take care of that for you, right?
Yeah. Next semester, hopefully we'll have model loading in, as well as a basic animation controller so you can get those things moving and doing stuff, as well as some type of model format and exporter so you can get them there as well. So.
I like that. This guy writes scripts for math.
We should hook you up with Chris Peters.
Also, we will bump up to 24-bit color at that point. Can we do 30-bit to 32-bit color? Yes. It's our output, our screen is capable of it, everything's capable of it, right? But you can just chug so much faster with less color, right? Because the data's smaller, right? So anyways, but we'll be able to handle 24-bit color as fast as we're handling 16-bit color now.
How much, wait, hang on, how much percentage of the way are we through the presentation? Like, will we be done by 7:30? What are we tracking for?
Maybe.
13 minutes.
Can you get to the cool stuff before 7:30?
Yes.
Okay.
I thought we were in the cool stuff, Rachel.
We're
I'll help you guys out with your presentation.
Alright, so we'll just hurry up and get to the cool stuff.
Oh, it is.
This is,
All right,
okay,
you want to see some cool stuff? See, we make hardware that works.
So earlier, Joe said that we have VGA, right? Well, we do. And this whole presentation was being done by this Augger thing right here.
But wait, I saw you on that keyboard.
Oh,
That's Bluetooth.
So using the Bluetooth technology on the Augger, you can use a PC or any other type of controller that uses Bluetooth, like a Wiimote. You can connect to the Augger and control it from far away. So that's why we want to be extra tricky and use the keyboard here.
That sounds like a security hole.
Yeah. We can do that for you too.
All right, now we're gonna get into the apps real quick. We'll try to go through them real fast. We're gonna start with like the basic input apps that we started with to kind of test values out. So that's what this is here. This is the compass. All this app really does is show you that the compass works. And when you put it all the way down, it rumbles. There's rumbling.
Okay, so
Next up is the graphics demo. What this has is just our software 3D stuff. It just has some particles in the back that are moving forward. You control the camera with the joysticks.
This is to prove that we actually have 3D already on the processor without waiting for the FPG whatever. And you gotta know too that like we're spending all our time like doing the hardware, and like a lot of this stuff you're gonna see now we threw together in the last week because we're like, oh, we should probably show them some demos and show them what it can actually do without having to explain it at the physics level or something, right? So
all right, this is a physics demo right here. Just basic blocks bouncing around. They have collision. Basically the same thing as the other one, the camera controlled by the joystick again. You see that there? It's a little disorienting because there's no frame of reference in this one. All right, now this is the accelerometer, just a quick demo of the type of values you're getting here and what happens when you tilt it. The red and green there are the Y and Z axis. And then the blue one is when you shake it, up and down.
it is XYZ, right?
Yeah, you can see the gravity vector there on the Z, blue. There you go. Check gravity.
Yep, so there, so there.
Gravity exists.
All right, and then this is going to be the camera that will show you that the camera can display right now to the screen. It's a little dark in here, though.
Cool. Oh, wow. Turn the lights on for a second.
I'm trying to.
Oh, not
Those-
there, over that.
yeah, those
that
lights
thing,
don't.
that
I
thing.
want the 25% because that's like.
No, the lighting is broken on that thing. Wow.
25%. I got the thing to work.
That's more impressive.
Oh, we're working on the camera.
All right, now we get into some of the slightly more interesting apps. This one is a touchscreen, basically drawing tool. You can go into that right now. And basically what it has is you can draw on the screen there with the pencil selected. You can change the colors over there in the upper corner and decide what they're on.
Also, this app was thrown together in about 3 hours. And I usually don't say that in like if it's my game or something, you know? I mean, that just shows how easy it is to develop quick apps on this thing, right? It's not going to be taking you forever to deal with. How can I deal with the touchscreen, and why does the touchscreen give me data about a temperature? Like, what's that all about? No, we have clean API. It does do that, by the way. Yeah. So we have clean APIs that help you get the information you need, right, to make it easy for you to use these. And we can always tailor make them for teams that are working on the Augger.
Yeah, question.
Is the touch screen single touch or multi-touch?
Single.
Actually, you can touch it, but you can multi-touch on it.
Yeah, it does averaging.
Yeah.
You can touch, but it's something
The temperature might change.
Is the cloth demo. It's simple, more 3D stuff again. Just shows a cloth, real basic cloth physics going down. And then, as you can see, the camera is controlled by the compass this time, actually. So you can move around, and if Chris wants to blow into the microphone.
So,
a little harder.
Start singing into the microphone.
at the beginning of the semester, the first thing Adam said he wanted to do on this thing, we told him, yeah, we have a 90 megahertz processor. And he's like, I want to do cloth simulation. And I'm thinking, no, 90 megahertz processor. And he did it. I mean, look at this.
Oh,
This
yeah, that is
really
one thing I would
impressive.
mention. You do have to use a lot of fixed points. You can't use really floating points for a lot of stuff because it starts getting a little slow. There's a lot of other little issues that you have to worry about when working on it, but you can do stuff with it if you know what you're doing. So this is another game here, the Water Strider. This was our first kind of game on it. You move around with this time with the accelerometer. Oh, this has music as well. You collect the flies and dodge the frog.
So he's using the tilt sensing.
Oh, God!
Play it.
Sorry.
We'll have to go back to that one. We'll go back to it.
All right. So,
Augerware, which was done by Joe here.
thank you, Adam. Yeah, I'm gonna have to play it because I'm actually pretty good at this game, I think. And the idea was